the answers to the AP practice problems I assigned yesterday. So what I'd like for you guys to do is just check your answers, correct any, try them again if necessary, and then I will have them all worked out for you for next week. So we have two more derivative formulas to look at from section 3.9, and then we're just pretty much going to review from 3.7 to 3.9, and then all of chapter 3, a test over 3.7 to 3.9, quite possibly by the end of next week, and then the following week, the test over all of chapter 3. So let's take a look at the other two derivative formulas that section 3.9 will have us looking at. All right, so if we're looking at y is equal to a to the x, we want to find the derivative in terms of x, where a is a constant. So here the power rule does not apply because these are exponential functions, so it's a little different. So what we're going to start with is we can only use what we have so far. And what we have so far is we know how to take the derivative of y equals e to the x and y equals the natural log of x. So if we could rewrite our problems in terms of either one of those, then we can proceed. And we can here. So if I start with y is equal to a to the x, and I go ahead and I take the natural log of each side, still just have the natural log of y, and I'm going to bring the x down in front. And then I'm going to go ahead and take the derivative of each side. All right, so we saw yesterday what the derivative was, or 2 days ago rather, what the derivative was the natural log of something. So the derivative of the natural log of y becomes 1 over y times y prime. Now over here, the natural log of a, since a is a constant, the natural log of a is a constant. And when we go to take the derivative of that, it's just our constant, or really a coefficient just happens to be behind it. So I'm just going to be left with the natural log of a. And then what I want to do is multiply both sides by y. So now I get that y prime is equal to y times the natural log of a, but we want this in terms of x. So if I go back up here, much like what we did when we were looking at the derivative of the natural log of x, y is equal to a to the x. So now y prime equals a to the x times the natural log of a. So to generalize this, we're just going to say if y is equal to a to some exponent u of x, then y prime is going to be equal to a to the u of x times the natural log of a times u prime of x. So I want you to take a look at this because it's still going to be the same for e of x. I just want to show you how this works. So whenever we're looking at this, y is equal to a to the some exponent here, it's still treated as the same as if we're looking at y equals e to the x. We could follow this same rule for e to the x. So y prime is going to become, so it's still a to the x here, so it just becomes e to the x times the natural log of e times the derivative of x, which is just times 1. But the reason this goes away, because the natural log of e is just 1. So that's why we were just saying the derivative here would just become e to the x times 1, or just e to the x. So any numerical base raised to some exponent function, u of x, will follow this rule. So y equals e to the x follows it too. It's just a little extra step we have to be aware of that shows it going to 1, but it shortens it up, and we just say that the derivative of e to the x is still e to the x. All right, so let's take a look at an example here that is not an e to the x problem. You guys pause the video, go ahead and try this. All right, so following the rule, we're going to have y prime is going to be pretty much this whole thing just rewritten. That's our a to the x here. So 5 to the 6 minus 3x times the natural log of a, that becomes the natural log of 5, times the derivative of the exponent, which becomes a -3. So we could write this, just put the -3 out in front, then we could say times 5 to the 6 minus 3x times the natural log of 5. It's not going to look any nicer no matter how we write it. One thing you can't do, though, is you cannot multiply the -3 with the 5. It has to stay the same. So if it makes it look a little bit nicer to you, you could just keep them in parentheses like this. And that's all there is to a problem like that. All right, so the next one is just looking at y is equal to log base a of x. So pretty much the first two formulas we looked at were dealing with e. We did the natural log of x, which is log base e. So of course these two are going to be similar. It's just e is a special case of logarithms. So again, a is a constant here. Let's take the y is equal to log base a of x. And then let's go ahead and rewrite this exponentially. So this becomes a to the y is equal to x. And the reason we did this is because the previous formula we came up with, now we can go ahead and take the derivative of both sides. So this becomes a to the y times the natural log of a times the derivative of the exponent, so y prime, and that's just going to equal 1. So solving for y prime, we get 1 over a to the y times the natural log of a. But again, we want this in terms of x. So if you notice right here, a to the y is equal to x. So now this becomes y prime is equal to 1 over x times the natural log of a. So to generalize, we'll just say if y is equal to log base a of u of x, again, keep in mind u of x has to always be positive. We'll have to remember that when we actually get to our problems here. Then y prime becomes 1 over u of x times the natural log of a times u prime of x. All right, so let's go ahead and take a look at an example. Here's what y is equal to. Let's go ahead and find y prime. Now my suggestion to you here is to rewrite this as log base 2 of x raised to the negative first power, so it's no longer a fraction. Pause the video, go ahead and find y prime. So if you still need more time, pause the video again. Okay, so first we have to apply the chain rule. So we're going to get y prime is equal to -1 times the quantity of log base 2 of x to the negative second. Then as we go to take the derivative of the inside, this becomes 1 over, so u of x here is just x, times the natural log of a becomes the natural log of 2, times the derivative of u of x, which is just x here, so it's really times 1. So to rewrite this, we're going to get just a -1 up top. We're going to have our log base 2 of x squared first, and then times x times the natural log of 2, or that could go out in front. Any order for that denominator is fine, but that is the correct answer. All right, so like I said, just adding 2 more formulas. The problems themselves are pretty straightforward, just applying the formulas to them, being able to recognize which formula we're using. All right, so as a separate PDF, I will have the solutions with work written out and posted to page 170, the 1 through 13 odd, 21 through 29 odd, and 22. Make sure you memorize these 2 new formulas along with all the other formulas from sections 3.7 to 3.9. Go ahead and try page 170, 14 through 19 all, 31 through 41 odd. Now on Tuesday of next week, I believe Monday's another teacher work day, So on Monday or Tuesday rather, I will be giving you guys the Inspire doc, or I'll have a video for it. There's, I think, 1 or 2 study card formulas, or study card Inspire docs for the derivative formulas for you guys to practice for the upcoming tests over 3.7 and 3.9, and then the one big chapter 3 test. So I'll give that to you on Tuesday, and then quite possibly by next Friday, I'll give you guys a test over 3.7 to 3.9. And then the following week will be the test over all of chapter 3, but I will be giving you guys plenty of review problems in the meantime and give you more information on the specific day for the big chapter 3 test. All right, so again, you guys have your quiz today. I'll be posting this obviously separately from the quiz, but as always, take care and let me know if you have any questions.